Hello everybody, in this lesson I will show you how to sketch a hyperbola step by step. Now there's a 4-point plan for sketching a hyperbola. The first thing you will do is you will decide in which quadrant your hyperbola lies. You will be looking at A's value. When A is greater than 0 or positive, your hyperbola will lie in the first and the third quadrant. When A is smaller than 0 or negative, your hyperbola lies in the second and fourth quadrant. The next thing you will have to decide on will be the asymptotes. Where do you find them? It's P's value. That one you call the vertical asymptote, and you will say x minus p is 0, therefore x is equal to p. Your horizontal asymptote will be y is equal to the q value. Number 3, step 3, x-intercept make y 0, as with all other graphs. Step 4, y-intercept make x 0. Then the domain for all the hyperbolas is x is an element real and x cannot be equal to p. And the range, y is an element real and y cannot be equal to q, that value over there. Let's sketch the graph of the hyperbola y is equal to 2 over x minus 1 minus 2. We will start with the quadrants. A's value is greater than 0 or positive. It's this value over there. Therefore, the quadrants are 1 and 3. 1 and 3. Step 2. The vertical asymptote x is equal to p. And this is where you will find it. So you will say x minus 1 is equal to 0. Therefore, x is equal to 1. And there is your vertical asymptote, the line x is equal to 1. Horizontal asymptote, y is equal to q, which is this value over there. Therefore, y is equal to negative 2. And there is your horizontal asymptote, the line y is equal to negative 2. Step 3 will be work out the x-intercept. The rule, make y equal to 0. So when we make y 0, we end with 0 is 2 over x minus 1 minus 2. Let the minus 2 walk across, and then now in this step we will get rid of the x minus 1 under the line, so we will multiply both sides. Therefore, 2 bracket x minus 1 is equal to 2. And then we will multiply in the 2. 2x minus 2 is 2, and we're going to solve x. 2x is equal to 2 plus 2. 2x is equal to 4. Divide away the 2 both sides. Therefore, x is 2. And then your x-intercept as a coordinate is the point 2 and 0. Step 4, y-intercept make x 0. So now we will make x 0. We end with y is 2 over 0 minus 1 minus 2. This will result in a minus 1, and 2 divided by minus 1 is negative 2. Therefore, y is equal to negative 2 minus 2. Y is negative 4. And that as a coordinate is the point 0 and negative 4. Then there's your hyperbola. Y-axis, x-axis. The x-intercept is the point 2 and 0. The y-intercept is the point 0 and negative 4. Now you also need your vertical asymptote, the line x is equal to 1. And you need your horizontal asymptote, the line y is equal to negative 2. Now I want to show you how to find the equations of the axes of symmetry, as well as the domain and the range. Now, first of all, the original graph, the equation for the axis of symmetry is the line y is equal to x, and this is this blue line. But our new axis of symmetry is only parallel to that line. It's a new line and we have to find the equation. So for a straight line, we start with y is mx plus c. And then we know that our axis of symmetry's equation will be parallel to the line y is equal to x. Therefore, the gradient is 1. It's the exact same gradient. And then your new axis of symmetry will pass through the point 1 and -2. And you find that point, that is the intersection of the two asymptotes. And the point consists of an x and a y coordinate. Therefore, you will end with -2 is equal to 1 bracket 1 plus c. And we'll solve c. -2 equals 1 plus c. -2, -1 is c, and c's value is -3. Therefore, your equation for the new axis of symmetry is y is equal to x minus 3. Now, when you go to the sketch, I will remove the line y is equal to x, and then your new axis of symmetry is the line y is equal to x minus 3. Let me write it there for you. Y is equal to x minus 3. Then your other axis of symmetry will be parallel to this purple line, the line y is equal to -x. Therefore, we will calculate a new equation, a new axis of symmetry. Therefore, y is equal to mx plus c. Then, as I said, your line will be parallel to the line y is equal to -x. Therefore, the gradient will also be -1. And then you will substitute the point 1, -2 into your equation. Where did I get the point 1, -2? That was the place of intersection of the two asymptotes. Into the equation goes -2 in y's place equals -1 bracket 1 plus c, and we will solve c. -2 is equal to -1 plus c. -2 plus 1 is c. C's value is -1. And the equation for the other axis of symmetry will be y is equal to -x minus 1. So there you find the line y is equal to -x -1. And this old axis of symmetry, that one will disappear. Then the question also asked for the domain and the range. Now, the rule for the domain, you write x is an element real, but x cannot be equal to p. And then where do you find p? There under the line. Therefore, the domain is x is an element real, x cannot be equal to 1. Remember, that is the asymptote. And then for your range, y is an element real, y cannot be equal to q. And where do you find q? It's that number over there. Therefore, the range is y is an element real, y cannot be equal to -2. Remember, that is the horizontal asymptote. In the next video, I will discuss a practice example on how to sketch a hyperbola. Click on the video in the left-hand corner to take you straight to the next lesson.